this will be the concluding part of the talk, and when we can just move to question and Q&A, kind of generic Q&A. So this part will be much lighter than the previous conversation, and it's just to highlight how much of the code base is available and potentially what part of the code bases can be used to realize the applications that we talked today So kind of overall, we have quite a bit of different code bases targeting various platforms. Structurally, you can separate them in a few categories, like there's infrastructure, creation software, there's a bunch of libraries that exist, a few pilot applications, and evaluation frameworks. I'll talk in a few details about some of them, but if you want more details, so the kind of the starting point and the ending point, and like spending a lot of time, you can just go to our NDN website. It's named-data.net. It has all pointers to, there's a long list of papers that you can read about. There's a pointer to all code bases, and of course pointers to the various tutorial talks. And we'll post this talk as well on the website as soon as we be allowed to do that. For the code base itself, most of the code is on a GitHub. We kind of try to organize it in different ways. So there is a generic code. Most of the code is under named data website kind of organization, but there are some specific parts under so-called -mobile, -IoT, and -NDN, and potentially there will be some other created in the future. And kind of to talk a little bit more about the supported platforms, we actually kind of, with initial focus was kind of on traditional platforms like Linux, OS X. Later, we actually expanded the support to more kind of mobile platforms and resource-constrained ones. So, for example, we also support so Raspberry Pi is actually basically a Linux platform, but we also have support for kind of very, very constrained devices that can run only specialized operating system like Riot OS. And the other kind of platform, it's kind of not really a platform, but something kind of semi-platform, is a browser platform. So this is kind of used a lot to kind of for initial kind of learning about NDN, initial playing with NDN, and to kind of highlight how it can work. So you can always download NDN.js library. So for that one, you probably need to do some form of HTTP request over traditional network, but then all the future communication can happen just using NDN communication. There is actually additional thing that you can completely avoid this HTTPS. If you venture to install Firefox plugin with NDN enabled, you can literally type NDN URL into the browser and kind of completely use all NDN, fully NDN-powered browser. So a few components that exist for the infrastructure part is our forwarding daemon. So this is effectively our software router. I'll just point out there's a kind of the link from our NDN website. There's quite a number of documentation. We also have a developer's guide if you're interested in kind of helping us to kind of improving the code. But you can also download this. There are binaries that you can download if you're using Ubuntu, or you can always compile from the source. As I mentioned, we also support several mobile platforms, and specifically we kind of using the same code base incorporated as part of the Android kind of application that is available on Google Play. So if you have an Android phone, you can always download NDN and kind of enable NDN stack and download a few pilot applications there. Or you can also kind of do it from the source. I mentioned NDN Riot OS platform. So this is kind of constrained version of our software forwarder just specifically for this platform. I mean, this platform is extremely constrained, and like it's a 16, maybe 32-bit processor, but kilobytes of RAM and very limited kind of storage spaces. There's a lot of tools that are available for debugging purposes if you want to play with this. So there's basically like NDN equivalent of ping tools, NDN equivalent of netcat tools, and various other things like Wireshark dissect, if you would like to kind of to observe what exactly happening with the traffic. But to be kind of get back to a little bit more specifics to our notional environment. So we talked about kind of actual basic packet forwarding, which effectively can be accomplished just with the NDN stack by the virtue of NDN or NFD running, or NFD Android or NDN Riot, depending on what platform you're running. For the kind of the application itself, you probably be using either NDN CXX library or NDNSea common client libraries if you're not using C++. We also have like large support of different languages like Python, Python, JavaScript, C#, normal Java, and I think there's a few others. Like there's one very interesting language called Squirrel. It's a kind of some version of JavaScript, but they just created such a cute name. So that would be effectively sufficient for the PLI application, so just NFD and CXX libraries, because it's very, very basic interest data exchange. And plus, you always need to do some kind of management of certificates using NDN cert, our kind of semi-library, semi-tool to semi-automatically provision certificates. You would also need the name-based access control. So this is effectively a library that you can plug into your application. There's a very, it's not too simple, but it's very simplified interface, so you can easily grant access to people who you want to get access. And most of the kind of this heavy lifting of creating a key decryption key, key encryption key is happening within this library. You can debug, you can observe what exactly is happening, but if you're not interested, then you can just live with that. And additional things that what Lan was talking about is NDN sync. We have a few versions of NDN sync. So she mentioned the chronosync, kind of our initial version. There is a psync that's kind of additional things, and there are a few other versions that pointed out kind of on the NDN website. Okay, so psync is kind of the latest version of sync that suited well for a managed environment. And one thing that I think we didn't talk too much today is a repository. So I think Tamer, Alicia, and Lan was mentioning about the concept of storage. So, and a lot of things we talked about was about the caching. But the caching is simply opportunistic storage, whether you can something be cached somewhere or not being cached. You cannot control over. This is just basically very, very opportunistic. And but the data that exists, the data packet, it's valuable even without the original producer in existence or caches or consumers who have requested this data. So you may want to have a kind of a generic storage system that you have kind of control, either you or a system administrator of the environment can control and can pre-publish some pieces of data like in different places of the network. So this semi-equivalent of CDNs, but kind of maybe even a simplified version of it, without targeting HTTPS, but just purely storage of data packets, and kind of whenever a request comes, those data packets can be used to satisfy the request. So we have one of the implementation of this NDN repo, and there are a few more optimized versions of this repository implementations are coming in near future. I think I covered most of the things that needed for the application. I may have missed some of the libraries, but again, we have several application examples that if you're interested to play around, so we can point to. And of course, debugging tools, that's the most important part of all evaluation process. So those kind of basic tools. Okay, I mentioned about the libraries. I'll just, you can get from the slides all those links, and I'll just move to a few things for evaluation purposes. So there are a few ways, if you develop the application, of course you can actually create your own small testbed, either replicate the notional environment and actually deploy things on whatever Humvees and maybe go to the satellites if you can. But we also have already built NDN testbed that spans like I think 4 continents and like many countries. And kind of this is a map of the testbed. And you can use this testbed if your application, if what you develop in actually makes sense in this environment. So, and this environment is not wireless, is not kind of, there's no broadcast environment. But if this is kind of the application that may suit this environment, you can try out. And we have been playing with the testbed since the day 1 of NDN, well, since we actually finished the developing initial version of our forwarder. Another way, if you don't want to use NDN testbed or you want to specialize the environment, there's also so-called Open Network Lab. So this is an emulated environment where you can request a set of nodes, like actual physical nodes, to run specific versions of the NFD or whatever other forwarder and specific versions of other components. So you can go online and register the account and kind of create those things. So the second kind of next level of fidelity, there is a tool called Miniendian. So this one effectively a kind of extension of Mininet framework for the purposes of creating emulated environment, kind of on a single node, create an emulated environment of the network and multiple nodes. So this one would allow you to do kind of basic evaluation of kind of on a single node, some kind of environment. Again, original version was targeting like point-to-point links or like Ethernet capable links. There is extension that I'm not sure what's the status of Miniendian Wi-Fi, but kind of there's also in works. It's in the works. Okay, so in works, hopefully it will be available soon. Additional kind of extension of Miniendian to support kind of emulation of Wi-Fi links. There's a few problems with that. And one more tool that has been quite popular in recent years is a simulation environment or simulation framework called NDN-SEA. So this one is effectively a module for NS3 simulator that runs exactly the same NFD and NDN-CXX code bases. It's just with a few tweaks to actually run them in simulated environment with the simulated time, with the simulated events. But with other respects, it's exactly the same code. So we're kind of synchronizing, like avoiding ourselves to do multiple jobs and kind of trying to improve fidelity of all the simulation results. So in the simulated environment, you can run basically everything that you can imagine, though it's probably in a simplified form. You have to sometimes reimagine your application or only create the application that's creating kind of specific data flows. But you can also, there's additional element that we created for the NDN sim is you can also kind of take your existing application, if it satisfies a few constraints that we listed on the website, and kind of plug it in a simulation environment. And if this application is simply like traffic generator like-ish, not too much of the UI, you can actually use that application for the purpose of driving the simulation environment. So it's kind of trying to move towards emulation, but still staying within simulated environment.